here?
Yeah, we're just, well, seniors, since we have a week left from tomorrow.
Wow.
We're just starting on the review packet where, like, everyone else is, like, learning stuff. We're just doing review right now.
Okay. So you only have 8
So,
more days of school?
7. Yeah.
Wow. Wow.
I know.
Okay. So.
I got my grade up, though, from the last test.
What's that?
I got a better score on my last test, and it brought my grade up, so that's good.
Well, good. Good for you, Emma. Glad to hear that. All right. Let's go through these.
I don't remember these at all.
Okay. All of these problems are basically rules of exponents.
Mm-hmm.
In fact, instead of looking at them directly, let me write the rules of exponents. Because there's really only 3 that you need to know. Okay? And here's what they are. If you have a base to one exponent times the same base to a different exponent, you add the exponents.
Mm-hmm.
For example, 2 cubed times 2 to the 4th equals 2 to the 7th.
Mm-hmm.
If you have the same base divided by the same base, different exponents, you subtract the exponents. For example, if I had 2 to the 5th divided by 2 squared, what would that be equal to?
2 to the 3rd?
Uh-huh. And there's only one more, really, and that is if you have b to the x, and that is being exponentiated, it's kind of what I call double exponentiation, then you multiply the exponents.
Okay.
If you had 2 cubed and all of it was to the 4th power, what would that be?
2 to the 12th.
Okay, those are the only 3 rules you need. Now, let's apply those 3 rules. So, in number 1, I'm multiplying the same base. Y is the base.
Uh-huh.
What's my answer going to be?
4 to the...
4y
Mm-hmm.
to the what?
You multiply these, right?
No, the bases, you never, always remember this, you never do with the exponents what you do with the base. So if the bases are being multiplied, there's no way you're multiplying the exponents. You're doing one level less. Add the exponents.
Okay, so 0.
Okay, what's y to the 0?
1.
Right. Every number to the 0's power is 1. That makes the answer 4. Okay? Number 2. I've got a couple things going on. The first thing you have to realize with number 2 is that the 4th power operates on the 2 and the z because they are both in the parentheses. In other words, whatever is in the parentheses is what that exponent operates on. So my answer is going to be 2 to the 4th for starters. And then what does that become?
Well, it'd be...
What am I doing? I'm doing double exponentiation, right? So what am I going to do with the exponents?
Multiply.
Right. One less level. Never the same. In In other words, I'm not going to exponentiate the exponents, but I'm going to multiply them. So what does this become? Z to the what?
1.
There's a minus 1/4 there, not a 1/4. That's minus 1/4.
Oh, so negative 1?
Uh-huh. And then usually they don't want any negative exponents on their answers. So what's that equal to? Simplify the 2 to the 4th and write the z to the minus 1 using a positive exponent.
So would you do like a fraction for that one, or?
Well, what's 2 to the 4th?
8?
2 to the 3rd is 8.
Oh. 16 then?
And what does z to the minus 1 mean?
That it's on the
1
side.
over z to the positive 1. It's always what negative exponents mean. Not quite sure why they give people so much problem. But if I have 2 to the minus 3, that's 1 over 2 to the positive 3. It's that simple. Nothing hard about it at all. The thing it does not mean is negative numbers. Notice that 1 over 2 to the 3 is 1/8. That's a positive number. So when you see a negative exponent, it does not mean negative numbers. It just means put it on the other side of the fraction bar.
Okay.
That's what it means. Simple as that. Nothing complicated at all. And that's your final answer, and it has nothing but positive exponents. Okay? Now, on a problem like number 3, start with the numbers, then do the next variable you run into, x, and then do y. And in other words, it's just one at a time. There could be 16 different variables here, and it wouldn't make the problem any tougher. We're just going to do one variable at a time. What's 24 divided by 4?
6.
What's x to the 9th divided by x to the 5th?
X to the 4th.
And what is y to the 3rd? Just y to the 3rd. There's no y in the denominator, so we don't have to divide anything. That's your answer.
Okay.
Okay. Now, number 4. Again, the most important thing is to realize that the minus 3 applies to both terms. So I could write this like this. That doesn't make it terribly understandable, so let's not write it like that.
Okay.
When you have a negative exponent to a fraction, the best thing to do is just to invert the fraction and take it to positive exponents. That's the same thing. In other words, always remember, those negative exponents just mean you put it on the other side of the fraction bar. So I'm going to put the 3 on the other side and make it positive 3, and I'm going to put the 4 on the other side, the numerator, and make it positive 3. Now, what's 4 cubed?
Hold on. I don't know this one off the top of my head.
Okay.
64.
Divided by 3 cubed?
27.
There's your answer.
And you can't simplify that, right?
That's correct. I can only divide 27 by 3 and 9, and neither of those go into 64. So that's simplified.
Okay.
All right, let's look at number 5. Number 5. My favorite way of handling problems like number 5 is to turn the radical sign into a fractional exponent. In other words, radical signs don't help a lot if I'm trying to use the rule of exponents, right? Because the rule of exponents, I'm either dividing, adding, subtracting, multiplying the exponents. So it's much better if I use the radical sign as a fractional exponent. What is a radical sign's fractional exponent?
Cubed.
1/2.
Oh.
If it was the cube root, it would be 1/3.
Okay.
If it was the 4th root, it would be 1/4. In other words, whatever the denominator of the fractional exponent is, that's the answer.
Okay.
Okay? Now, let's simplify that. We have to apply that 1/2 to all 3 terms. So, I'm going to start by saying 18 to the 1/2.
9.
No. Square root of 18 is not 9.
I'm confused.
Okay? What 1/2 means is square root. What's the square root of 18? It's not 9. 9 times 9 is 81.
Oh, I thought it was half of the...
No. That's 2 times 9. That's not what square root means.
So you're essentially just saying 18...
No, this is what it means. Square root of 18. Well, what number multiplied together gives you 18? It's like 4 and change. It's not 5. 5 times 5 gives you 25. 4 times 4 gives you 16. So it's a number between 4 and 5.
It says 4.24.
Okay? That's not the answer I like. And I'll tell you why, is they don't want decimal answers here. They want you to give them a radical answer. Do not use calculator. That means we need to reduce that. Well, that's the square root of 9 times the square root of 2. Square root of 9 is 3. So that becomes 3 root 2.
Okay.
And I would have done that, but you got to give me a chance to get to it. In other words, we're doing one step at a time.
Okay.
I'm just writing it as 18 to the 1/2 because that's what it is, 18 to the 1/2. Now, what's the x term going to be?
Would it then just be x to the 3rd?
Good. And what's the y term?
4 to the...
Y to the...
Y to the... Sorry, it looked like a 4 on my paper.
Okay.
To the 2.5?
Don't give me proper fractions. Improper fractions are far better than proper fractions. I don't like improper fractions. I don't even like to write them. So I'm going to write it as an improper fraction. Okay?
Okay.
All right. Now let's simplify that. What's the square root of 18? Well, as I said, that's the square root of 9 times the square root of 2. Square root of 9 is 3, and square root of 2 is what's left over. Now, I'm putting it back into radical format because most teachers, if they give you the problem in radical format, they want the answer in radical format. Okay? So I don't give the answer as 18 to the 1/2. I don't give it as the square root of 18 because that could be simplified. But 3 root 2 is the perfect, exact, non-calculator answer for the square root of 18. Now, I still have an x to the 3.
Mm-hmm.
And now I have a y to the 5 halves. I can actually separate that as y to the 2 times y to the 1 half. See why?
No.
Well, because if I had y to the 2 times y to the 1 half, I would add the exponents.
Mm-hmm.
That would be 5 halves, 2 and a half.
Mm-hmm.
Okay, so I can separate it. In other words, if you can add these, you can certainly separate these. You've got to always be able to do the reverse. Okay, and there's a reason why I'm doing this. That's kind of my answer. Only y to the 1 half, if I want to put that back in radical form, that's square root of y. Okay? Now notice that I got two radicals in this expression. I got radical 2, I got radical y. Everything else is outside the radical sign. So I can write the answer this way. Since I got a radical 2 times a radical y, I got a radical 2y. There's my answer.
Okay.
Okay? And that's not a particularly easy one to get to because there's a lot of simplification required. The first thing is to multiply the exponents and put it in this format. Second thing is to reduce the square root of 18 to 3 root 2. Don't have to do much to the x term, that's x cubed. But the y to the 5 halves, because I don't really want to give that as an answer because I want to give a radical sign back as the answer if I've got one. And so I can pull a y squared out of that, leaving behind a y to the 1 half, which is square root of y, combined with square root of 2 gives you square root of 2y. And that's the perfect answer. It's possible that you might get away with an answer that's close to that, although I doubt it. Your teacher's at least going to want you to change the square root of 18 into 3 square roots of 2. But they may accept the rest of that. In other words, without you combining the 2 and the y.
Okay.
I don't know. Kind of depends on your teacher. All right, cube roots. Now, since there's only one number there, there's no point in me writing this as 128 to the 1/3. That doesn't help. It's correct, but it doesn't help. What I'm looking for are factors of 128 that are perfect cube numbers. Just like when I'm trying to simplify square roots, I'm looking for factors of the number inside that are perfect square numbers.
Well, 64 times 2.
Perfect. I was going to get there. I was going to write the perfect cube numbers over here on the right, but you picked one right away, 64. So 64 is what? So, okay.
8 root 2.
No.
But then it'd be...
No, hold on. No, it's
then
not.
root 2 would be 1.
No, it's not.
Then it'd just be 8.
Just a second.
Oh.
This is our first step, right?
Right.
What's the cube root of 64? Not the square root. Not the square root. The cube root. What number multiplied by itself 3 times equals 64? And I'll give you a hint. It's a low number.
Is it?
What's 2 cubed?
Four.
No, don't use your calculator. What's 2 times 2 times 2?
Oh, 6, 8, 8.
Okay, what's 3 cubed?
3 cubed is 9.
Nope. 3 squared is 9. 3 times 3 is 9. 3 times 3 times 3.
27.
Okay. What's 4 cubed?
64.
Ah, there's your answer. If 4 cubed is 64, then the cube root of 64 is 4.
Okay.
And you should memorize your 2, 3, and 4 cubed. You should know them.
Normally they give us a sheet
I know,
up to 13.
I know. But you want to memorize the low numbers. Even
Okay.
maybe 5 cubed, which is 125.
Yeah.
That's where I stopped memorizing it. After 5, I don't memorize it anymore.
Okay.
Okay, so I would memorize 2 cubed, 3 cubed, 4 cubed, and 5 cubed. Now, that gives me my answer as 4 times the cube root of 2. And I certainly cannot simplify that. And that's in radical format. So that's the answer I want to give them. And I never converted this to fractional form, exponents, because there was only one term. There was a number in the middle. As opposed to number 5, where there was a number, an x variable, and a y variable. I found it easier to do number 5 by converting the whole thing to a fractional exponent, multiplying the exponents. But in this case, I didn't need to do that. So all I had to do was separate 128 into 2 factors, one of which was a perfect cube number. Now, your perfect cube numbers are not, they're 8. That's 2 cubed. 3 cubed is 27. 4 cubed is 64. 5 cubed is 125. They go up pretty fast. That's why I only remember that, because I'm usually looking to divide by one of those 4 numbers. I'm looking for factors that are one of those 4 numbers. Well, in this case, 64 was 1. All right. What's z to the 5th plus z to the 5th?
Z to the 10th.
Let me give you this problem. What's z to the 5th times z to the 5th?
Z to the 25th?
No. Remember, you never do with the exponents what you're doing with the base. I am multiplying the z.
2z to the 10th?
Just z to the 10th. When I am multiplying the base, I am adding the exponents.
Oh, but...
So that tells me that z to the 10th can't be right for that, because this was z to the 5th times z to the 5th. All right, I want you to look at this in a slightly different way. First of all those rules for exponents involved either multiplication, division, or double exponentiation. Did not include addition or subtraction. So if I'm adding a z to the 5th plus another z to the 5th, how many z to the 5ths do I have?
2.
That's the answer. Now, let me ask you this. If I had a z to the 5th plus a z to the 4th, what do I have?
2z to the 9th?
No. I have this. I cannot simplify that. I'm adding 2 different things. Think of a z to the 5th as an apple. Think of a z to the 4th as an orange. I cannot add 1 apple plus 1 orange.
Okay.
But up here, my z to the 5th is an apple. I got another z to the 5th. That's another apple. If I add 1 apple plus 1 other apple, I got 2 apples. 2z. So when you're adding or subtracting, you can only add or subtract like terms.
Okay.
That's why I could add z to the 5th plus z to the 5th, but I could not add z to the 5th plus z to the 4th. Z to the 5th and z to the 4th are not like terms. So I cannot add them together.
Okay.
All right, let's have a look at number 8. Do the numbers first. I'm
So
going to put a fraction bar over here.
1/2.
Well, what's 3 divided by 9?
Oh, 3.
Well, if you're doing the numbers first, this is the only part we're looking at. We don't care about anything else.
1/3.
Okay? So that's 1 in the numerator, 3 in the denominator. Now, let's do the x's next. What's x to the 4th divided by x to the minus 2?
X to the 2.
Subtract the exponents. When I am doing division, I am subtracting the exponents. So 4 minus a minus 2 is what?
6.
So that's in the numerator, x to the 6th. Okay, now we've taken care of that, and that. Now let's do the y. What is y to the minus 7th divided by y, and there's a 1 there. You just don't see it. They don't write it. Subtract the exponents. What does that become?
Y to the negative 6.
It's minus 7 minus 1.
Oh, minus 8.
Okay, so it's y to the minus 8. That's also in the numerator for the moment. Now z. Finally, let's do z. Always doing these one at a time. There's no need to do more than one at a time. What is z divided by z to the minus 2? Subtract the exponent.
Z to the negative 2.
What's the exponent in the numerator?
1.
Subtract the exponents. 1 minus a minus 2. Do not drop negative signs. Everybody wants to drop negative signs. Everybody seems to think that if you have two negative signs together, you can drop one of them. You cannot.
3.
Okay. And that's also in the numerator for the moment. In other words, all of these are in the numerator until I decide I want to move them to the denominator. Which one needs to be moved to the denominator?
The y.
Okay. So now I don't need this 1. So here's my final answer. X to the 6th, z to the 3rd, all over. That 3 is still in the denominator, and the y to the positive 8 now goes in the denominator. There's my answer.
Okay.
It's real straightforward. Do one thing at a time. Subtract the numbers. Do not drop negative signs, and you can't miss it.
Okay.
Number 9. Now, first of all, number 9 has a multiplication sign there. We don't really need that. In other words, if that wasn't there and this was just all one string of figures, be exactly the same thing. In other words, this is the same, and it's important that you understand this. Exactly the same as this. In other words, I can remove that dot. Just put all the numerators together and all the denominators together. Okay? So that's the first thing. Now, combine all the numbers. I got a 24 there, I got a -8 there, and I got a 4 there. What does that equal, and is it in the numerator or the denominator?
What?
Here's what I got. 24 times -8 all over 4. I'm doing the numbers first. Then I'm going to do the x's, then I'm going to do the y's. So reduce that.
6 times -8.
Okay, so what is it and where is it? In the numerator or the denominator?
The numerator.
Okay, and it's -48. 6 times -8 is -48. So that takes care of that, takes care of that, takes care of that. Now let's do all the x terms. We got x to the 10th in the numerator. What are we going to have in the denominator after we multiply these two together?
X to the 7th.
5th. You add the exponents. Here's the thing, Emma.
On the bottom?
Yeah.
Well, I was doing the 2
Oh,
minus 3.
okay. In other words, you were doing x to the 10th divided by x to the 3rd, which is x to the 7th, whereas I was trying to do it all together like that.
Yeah, now I see
We've
that.
got two x terms in the bottom. So that's the same as x to the 10th over x to the 5th, which is x to the 5th in the numerator.
Okay.
Crosses that out, cross that out, cross that out. The only thing we have left is y. What is it? You got a y to the 3rd times a y to the 4th.
Y to the 2, wait. Yeah.
Hold on.
Y to the...
Tell me what that is. Y to the 3rd times y to the 4th.
Y to the 7th.
Correct. In other words, you're adding. The one thing to remember so you won't make mistakes is you're never doing to the exponents what you're doing to the base. Well, my base I'm multiplying. So there's no way I'm multiplying those exponents, which means I got to add them. Okay, so it's y to the 7th. Now, notice I don't have anything in the denominator, and I don't have a need to put anything in the denominator. In other words, I don't have any negative exponents anywhere. If this was an x to the -5th, then I would put a line there, and I would put it in the denominator as x to the +5th. But since everything has a positive exponent, that's my answer. Put a 1 under there if you like, but we don't generally do that. All right. Trying to think of where we left off. We left off at 9. Let's do 10. Now the first thing to notice about 10 is that everything in the parentheses is being taken to that -2 power. So to me, the easiest thing to do is let's multiply that -2 immediately and get rid of it. In other words, I'm going to take this and I'm going to get rid of the -2. I'm going to get rid of it by multiplying it. I'm going to apply it to every term I'm looking at. Because every term I'm looking at is it's to the -2. Okay, so it's relatively straightforward. It's 3 to the -2 in the numerator, and it's y to the -2. Stop me if you don't see what I'm doing. What's z in the numerator?
-2.
Now you got to multiply those two exponents. Remember, I am doing double exponentiation here. When I am doing double exponentiation, that's when I multiply the exponents. I'm not multiplying z times anything. I'm taking z to the minus third to the minus second. Multiplying the exponents gives me z to the plus sixth.
Mm-hmm.
Now let's look at the denominator. Well, let's start out by saying that. 5 to the minus 2. What's the y term in the denominator?
Y to the minus 4.
Okay. What's the z term in the denominator?
Z to the negative 2.
Good. Now we've got an easier problem. In other words, we've taken what was a complicated double exponentiation problem and we eliminated the other exponent. Now, one thing that's really worth knowing with negative exponents.
Mm-hmm.
If you have a negative exponent, you can take that thing and just move it on the other side of the fractional line. So my 3 to the minus 2 becomes 3 to the 2. You with me?
Mm-hmm.
And it goes both ways. I've got a 5 to the minus 2 in the denominator. Let's move that to the numerator, 5 to the plus 2. So that takes care of that and that. Now, instead of doing that same process, let's just subtract those exponents and see what we get for y. And it's going to be in the numerator for starters. In other words, what is y to the minus 2 divided by y to the minus 4? Subtract the exponents. Do not drop negative signs.
So would it just be 2?
Perfect. And it's in the numerator, always. When we're doing it like this, it's always in the numerator. Now, if it ends up with a negative exponent, I might move it into the denominator after that. But when I'm doing these processes, my answer is always in the numerator to whatever the exponent is. And I'm subtracting, so it's minus 2 minus a minus 4. And that's how you got. Okay, now how about z? Do not drop negative signs.
4.
You dropped a negative sign. It's not 6 minus 2. It's 6 minus a minus 2.
Yeah, so it's a plus.
That makes it 8.
Oh, yeah.
Okay, so it's z to the 8th in the numerator.
Mm-hmm.
Now, I pretty much have, I don't see any negative exponents. So all I got to do is simplify these numbers. What's 5 squared?
25.
Times y squared times z to the 8th all over 9. There's your answer, all positive exponents.
Okay.
Okay, and notice how many negative exponents I started with here. My goodness, when we did the first step, we had a negative exponent there, 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 and there. We had 5 negative exponents there.
Mm-hmm.
But notice when I put that on the denominator and I put that on the numerator, that took care of 2 of them. And then when I merely subtracted those, that took care of 2 of them. And when I subtracted those, that took care of the 5th one. So I didn't even have to move anything at the end. All my negative exponents became positive.
Mm-hmm.
Which you want. You don't want your answers to have negative exponents. That's just kind of a rule teachers use. All right, square root of 108. Now, when I run into a problem like this, Here's my perfect square numbers over here. 4, 9, 16, 25, 36. What I'm looking for is, are there any factors of 108 that are one of these perfect square numbers?
Yes.
Which one? What's the biggest one? That's
30.
really what we're looking for, is the
Yeah.
biggest factor.
36.
Yeah. So that's the square root of 36 times the square root of 3. No,
Mm-hmm.
that's 6 root 3. That's the answer. Okay? Now, let's say you didn't realize that 36 was, but you knew that 4 was. Not 4, excuse me, 9. In other words, I can see that that is divisible by 9. Why? Because the digits all add up to 9. If the digits of a number add up to 9, the number is divisible by 9. That's a great thing to remember. Because a lot of times you want to know if it's divisible by 9, particularly since 9 is a perfect square number. So it would be 9 times 12. Well, that becomes 3 root 12. But then root 12 can be broken down. Root 12 becomes root 4 times root 3. Root 4 is 2. So I end up getting the same answer, 6 root 3, as I got when I used 36. It just took 2 extra steps to do it. So you don't always have to figure out the maximum perfect square factor, but it makes it shorter. You get it done quicker if you do 36 times 3. Because then, in one step, look, this took me 4 steps. There's step 1, step 2, step 3, step 4. Whereas when I recognized that it was 36 times 3, well, now it becomes, that's step 1, that's step 2, done. So it always is going to be quicker if you recognize the highest perfect square factor. These kind of problems, but not necessary. In other words, as long as you recognize that 9 is also a factor, you'll eventually get to the right answer. It'll be a little slower, but so what? The point is to get to the right answer.
Okay.
All right. I presume the ones with the X we're not to do those?
Yeah, she said skip those.
Okay. 15. Looks intimidating, but it really isn't. I want you
It looks like it'd be just 0, but...
No, foil it.
Ew.
I want you to foil it exactly. And you know what foil means?
Yeah.
Because they don't always teach foil anymore. I get about 1/3 of my students that don't know what foil means.
I do.
It's because the tendency now is to not teach foil, because foil only works with 2 terms times 2 terms. If I got 3 terms times 2 terms, foil doesn't do me any good. ET is what I like. ET means you multiply every term by every term. So let's do that. And ET works on 2 terms times 2 terms, or 3 terms times 4 terms, or 3 terms times 2 terms. So ET works with everything. So give me the ET answer here. What's the first term? And always establish a pattern and stick with it.
16 plus, or I don't know what 4, would I multiply the 4 just by the -3, not the root 2? Or would I do them both?
Correct. In other words, that's minus 12 root 2. That's what that times that is.
Okay, so first and then plus 12 root 2, and then that'd cancel out, right?
Right? But let's finish it before we do all that.
And then last is negative 9 root 2.
Now you got to multiply the root 2's by each other.
Oh.
In other words, if I'm multiplying this by that, then you're right, it's negative 9, but root 2 times root 2 is 2.
Mm-hmm.
So it's 18 is what that last term is.
Okay.
Now, simplifying it's pretty easy. That cancels with that. And I got 16 minus 18 minus 2 is my answer.
Okay.
Okay? All right. This over here looks like a division problem, but it really isn't.
Okay.
It's a rationalize the denominator problem.
Mm-hmm.
In other words, if I gave you an answer such as this over here on the right, you would rationalize it how?
What do you do it like 3 over
No.
2 to the 1/2?
The only thing I'm allowed to do is multiply this fraction by the number 1. Well, in this case, the number 1 is going to be root 2 over root 2. And notice why that gets rid of the irrational denominator. Root 2 times root 2 is 2. The top becomes 3 times root 2. There is the rationalized answer.
Oh, okay.
Okay? So, and the reason it's rationalized is because math does not like irrational denominators. So whenever you see an irrational denominator, you need to rationalize it. And if it's just a single term like this, it's pretty easy. You multiply the top and the bottom by whatever the bottom is.
Uh-huh.
However, when it's like the problem we have here, it's a little more difficult. You got to multiply the bottom by the conjugate. Square root of 2 minus 1. Always. And if I'm multiplying the bottom by that, I got to multiply the top by that, because remember I can only multiply that fraction by the number 1.
Mm-hmm.
Now, expand that. What's the top?
3 root 2 minus 1.
Minus 3. Got to multiply the 3 by both terms.
Oh.
Now, you'll notice something happens when you multiply the bottom. We're going to lose the radical sign.
Uh-huh.
What is the
So,
bottom? What's square root of 2 times square root of 2?
4.
Oh, this is 2. Square root of x times the square root of x is x.
Okay.
So the bottom is 2 as the first term.
Mm-hmm.
And notice that the next 2 terms are going to go away again. They're going to cancel out. That always happens when you're multiplying by the conjugate, and that's why we multiply by the conjugate, is to get rid of those 2 terms. And then there's a minus 1 that you get from that times that. So my answer becomes 3 root 2 minus 3 all over 2 minus 1, which is 1, which means my answer is that.
Uh-huh.
And the only thing you have to remember is multiply by the conjugate when you have one of these funny denominators.
Okay.
Okay? Oh, we got another funny denominator. What are we going to do?
Multiply it by 1
Not
over
1,
3
the conjugate.
over root 3.
Nope.
4 minus
What
root
is the
3 over 4 minus root
conjugate
3.
of 4 minus root 3? It's 4 plus root 3.
Oh.
Conjugates are easy. What's the you still there? Emma? Emma, did I lose you? I lost the audio.